Dark matter is indirectly detected by gravitational lensing and galaxy rotational curves. Today I am going to talk about the galaxy rotational curves. Most of you might be familiar with the gravitational lensing. Galaxy rotation curves are rare, but there are a few times they have given it in the exam. First, we'll check a rotational curve for our solar system. So when a planet goes further away from the sun, the rotational speed will decrease. Rotational speed is inversely proportional to square root of the radian. We can easily prove it using centrifugal force equal to gravitational force and simplifying it. So according to Newtonian mechanics, if there's a central mass like our sun, okay, so when you go along the solar system, when you go further away from the center, when the radius of the planet increases, the rotational speed of the planet should decrease. This should be same for the galaxy. At the center of the galaxy, there's a supermassive black hole. In our Milky Way, at the center of the galaxy, there's a supermassive black hole. All the other solar systems are rotating that supermassive black hole. Now we can sketch the graph for galactic rotational speed. As in, we consider the supermassive black hole at the center is the central mass. Orbiting other solar systems are the orbiting masses. So we should see the same pattern that we see in our solar system. But it didn't happen. We start seeing when you go further away from the central mass, when you go further away from the central mass in the galaxy, the speed of the stars further and further away, not decreasing. Speed of the stars further and further away is not decreasing. It's actually increasing. So there should be some unknown kind of matter inside the galaxy exerting gravitational forces on these stars. So this will give evidence for existence of dark matter or indirect observation of dark matter. This is what it looked like. Okay. Then there's another method that's called gravitational lensing. But today I'm going to concentrate on galactic orbital speed curve. Again, I'll repeat. For a galaxy, center of the galaxy, there's a supermassive black hole. All the other solar systems are orbiting that supermassive black hole. So when you go further away, if there are no other masses, if there is only the central mass, inside the galaxy, rotation speed of the other objects and other solar systems should decrease as in our solar system. But it's not happening. So that's the evidence for existence of dark matter. This is what it looks like. This one is with dark matter, spinning fast. The tails are spinning fast. The other one is without dark matter. We're expecting that one, but we got this one. Further away, when you move away from the galaxy, the solar systems are moving higher and higher speeds. Evidence for existence of dark matter. This is what we are expecting. Like in our solar system, when you go further away, the things should slow down. If there's only a central mass, the things should slow down. But there is invisible matter in a galaxy. That's why these things are speeding. I repeat, dark matter is indirectly detected using gravitational lensing and galaxy rotational curves. Not detected, indirectly detected. In a question, if there's option dark matter is detected, that is wrong. Dark matter is indirectly detected, or there's evidence for dark matter. There are two evidence for dark matter. We don't know what is dark matter. We only know about two things. Dark matter does not emit any kind of electromagnetic radiation, but it exerts gravitational forces like other metals.